This is an orthokeratology case where the patient's lenses are decentering a little bit, and there's a little bit more remaining cylinder in the prescription. I think there might even be some induced cylinder in the prescription. And if we look at the posterior topographies, this is with the initial set of lenses and a little bit temporal movement. With the second set of lenses, it's temporal and it's also dropping down a little bit. If we look at the lenses, it's interesting. The second set is a little bit steeper in the periphery in this meridian, so it's bearing down more on the cornea. But if we look at the topography, we're actually getting the flattening in this meridian. So it looks like this lens might be turning on the eye and not orienting the way we anticipated. And the same thing happened in the left eye. The second lens is steeper in this meridian, but we see the flattening 90 degrees away on the posterior topography. So I think the best thing to do is probably combine some of the fitting philosophies from both the first and second lenses. One thing that seems to have helped the second design is adding the asphericity. And this gives us more of a homogeneous treatment zone, and I think we do want to maintain that to see if we can get it shifted closer to the visual axis. So I would use a peripheral profile similar to lens number 1, but with the asphericity that's present in lens number 2. Sometimes with this irregular treatment zone, we just need a little bit more bearing centrally, and adding the shape factor does help with that. So I'm going to kind of minimize the second lenses, and we'll use your first pair as the starting point. Another thing I would change also is maybe go a little bit bigger on the overall diameter. I think we can go maybe about 11.5 or 11.6 on this particular cornea. And we have to readjust our center thickness to match. And I think he had a shape factor of, you notice it changed our power a little bit there. At 11, we're at a plus 1.41, and we want to maintain that because I think the spherical component of the posterior refraction was right at plano, and so our target is pretty good, and just we want to keep that in mind also when we change the shape factor. We have a topo demand of 5.24 and a lens power of 1.41. So going back to our slightly larger lens, I'm going to increase this so we're right at 1.41 again. It looks like that one was closer. Although this one closer on the topo demand. Okay, we'll add in a shape factor. I think you had 25, which is fine. 20 or 25 usually works pretty well. And you'll see that drops the apical clearance down towards the cornea a little bit. We do have to readjust though, our topo demand went down, so I'm going to raise that back up to 524. Okay. And then that last thing I'm going to do is go around to the different meridians to make sure we're still fairly even all the way around. So we're at 1.69 here, and yeah, that's pretty different, so I'm going to try to even this out. We're really off there. Okay, so now we're more consistent all the way around, but you'll notice our topo demand is a little bit high now. So I'm going to go back to 100%, and we'll drop down everything. And now we're pretty close to our 5.24, and we should be pretty close to 1.42 all the way around. Looks like we can be a little bit closer. I think I might touch that up just a little bit. We're not that far off. Okay, so we're pretty consistent all the way around in terms of lens power, and our average depth of demand is the same as the very initial lens. So this lens is going to bear down a little bit more peripherally. Not much change in the edge profile. Um, there was a little bit of temporal decentration with the first lens, but it wasn't bad. Um, and I would give this a try first. So if the cylinder part of the refraction still persists, then you may consider going to an oval treatment zone, but if that's not necessary, I kind of don't want to introduce more complication than we need. So I would do the same thing to the left eye, increase the overall diameter, maintain the same power and topo demand, and then adding the asphericity to bring the center of the lens down closer to the cornea a little bit. Hopefully that'll smooth out the vision centrally, and the lens will be centered enough where the patient will get a good result. So I hope this helps. Good luck with the patient, and thanks for watching.